Hello everyone, let's look at the following problem. Formally, you have two infinite sequences. For each I, A of I is equals to X XOR I, and B of I is equals to Y XOR I. You want to find the greatest M such that there exist I and J. A of I is equals to B of J. A of I plus 1 is equals to B of J plus 1. And all the way to A of I plus 1 M minus 1 equals to B of J plus M minus 1. So the steps to solve the following problem is the follows. First step, we are able to find out that A of I equals to B of J is actually equivalent to saying that X XOR Y is equals to I XOR J. Now the second step is that we we want to convert the condition of M into the following. I XOR J is equals to X XOR Y. And I plus 1 XOR J plus 1 is equals to X XOR Y. From these two conditions, we can get that I XOR I plus 1 is equals to XOR J plus 1. Now, let's look at the third step. What exactly is I XOR I plus 1? Now, if we represent, it is actually 2 to the k plus 1 power minus 1, where k is the low bit of I plus 1. In other words, by saying this condition, we can actually mean that the following. Now, if M is the answer, we'll have a list of. Now, if M is the answer, we must have low bit of I is not equals to a low bit of J. Otherwise, we can deduct I and J by 1 so that M will increase by 1. If we start from I minus 1 and J minus 1, then M will increase by 1. Therefore, let's suppose low bit of I is smaller than low bit of J. Then let's suppose low bit of I is smaller than low bit of J. Suppose here is I. And here is J. You can see that low bit of I is actually smaller than low bit of J. So let's find the greatest m in this case. If m increased by 1, they will their lobit are the same, right? Because now let's look at this case. First, we can see that I plus 1's lobit is indeed equals to j plus 1's lobit. So lobit of A1001 is equals to lobit of B10001, right? Um, First we can see that their lobit are indeed the same. So this is a good example of I and J. From this we can see that their lobit are indeed the same. In this example, the lobit of I is 3, while the lobit of J is 4. When I and J increase by both 1, the lobit of I become 1 and the lobit of J becomes 1. When I and J increase by both 7, their lobits are also the same. I becomes, in this case, I becomes A1111 and J becomes B10111. However, if we increase I and J by 8, which is just 1 higher than 7, their lobits become different. Because in I, it will becomes this, while in J, it will becomes this. So you can see that from now, the lobit of I is 4, while the lobit of J is only 3. So we can definitely see a pattern here, which is that if we increase I and J by both the lobit of I, in other words, by both the lobit of I, which is 8, then their lobit will become different. Therefore, in this case, M is equals to the lobit of I, which is equals to 8. In other words, if we find I and J based on their lobits, here's the first step. Let's go back to the initial problem. Now, the third step actually tells us that for a certain I and J, M equals to the minimum of lobit I and lobit J. Now, here's our final step to solve this problem. We can go back to the initial condition that I XOR J is equals to X XOR Y. From this condition, we can actually know that M equals to the lobit of X XOR Y. And this is the maximum value that we can get. Now, to prove that m is actually this value, I will give a construction and give a proof that m is impossible to be greater than this. First, a construction. We can pick I is 0 and j is x, or y. Then the m that we can get, which is mean of low bit of I and low bit of j. This m, because low bit of I is infinity and low bit of j is the low bit of x, or y. So the m value in this case is low bit of x, or y. So from this from this construction, we can see that m can be the value of low bit of x, or y. Now I'll prove that it's impossible for m to exceed this value. Suppose m is greater than the low bit of x, or y. This means that the low bit of I and the low bit of j are both greater than the low bit of x, or y. Now this is actually impossible because I XOR j is equals to x, XOR y. So let's suppose that their low bits are both greater than the low bit of this, then I must um suppose now because XOR is a bitwise operation, so let's look at the bit of low bit x, XOR y. Now suppose x XOR y is this A1000, okay? And because low bit of I and low bit of j are both greater than the low bit of x, or y, which means that their low bits are 4 or more. So let's assume that I is B10000 while j is C10000, okay? Then when we do the bitwise XOR operation, this bit, which is the fourth bit, will give us 0. However, the bit of x, or y will give us 1, which means that I XOR j is not equals to x, or y. So this is false. Therefore, because of the construction and the proof, m must be the low bit of x, or y. So the problem is over, and thank you for listening.